Hey guys, and welcome to the first video of 2024. In this video, I'm going to present an interesting and efficient way to time your Python code. And I want to start off with a common example I see, and I want to argue the case as to why this example using the time module is not very good. Suppose you want to time some code, and first of all, why would you even want to time your code? Well, suppose you're building an algorithm and you need it to run as efficiently as possible. Well, you might want to get a benchmark for how quickly it is, make improvements, and keep on running your tests to get it as efficient as possible. So basically what you can do, and this is a very primitive way, is start some kind of clock, do your function, pause the clock, work out the difference. And that's it. So in this case here, I've got a very inefficient function to work out if a number is prime. I'm basically passing in a num here, which is an integer, and we're simply saying for all the numbers between 2 and that number, if that number evenly divides, add it into here, and at the end essentially return if that list is not empty or not. So if I, for example, was to do 7, come down to the terminal and run, we get true, 7 is prime. Say we try 10, that list will contain divisors, and we get false here. And for our timing mechanism, we've simply done from time import time, so this does Unix or epoch time, which is the number of seconds since the 1st of Jan 1970. We set it off, Python's going to do some stuff, we get another value, just work out the difference. Now, there's a few reasons as to why doing this is bad, and I want to present 3 arguments, and we'll then go on to a better alternative. The first reason as to why doing this is not particularly great is because your computer's doing other things at the same time. If your computer's doing a lot of CPU intensive stuff at the same time, that could potentially skew the results you're getting from this here. Because this uses your system clock, your CPU could be doing video stuff, it could be rendering web pages, it could be doing a whole lot of stuff at the same time, and this is potentially going to skew it, arguably not by a whole lot, but if you want the most accurate result as possible, this is a pretty bad idea to do. The second one is that this really isn't designed to do this, especially knowing that there's a second module out there called Timeit, which we'll see later, that is designed to time code. I'm a bit reluctant to use modules for things they're not specifically designed to do. But that's just me. People may choose to use a time module for other stuff, and that's completely fine. But that's just my opinion. At the moment, this is just doing a single run. So if we go ahead and run this code here, it's doing this once. Now, of course, you could set up a complicated loop to, make this start at the start of a loop, and store the results in some kind of list and do the average. But that's an awful lot of work to do just to work out how quickly your code is going. So again, I think that's probably my biggest one, is that it's not very repeatable unless you want to add loops into your code, which then at the end you then have to remove, and it just gets a bit messy. So those are my 3 reasons as to why I wouldn't be doing this. What I want to do now is clear the screen, jump into a new file, and I want to introduce the built-in module Timeit. So here we are in a blank window. So the first thing I've gone ahead and done is imported Timeit, and because this is a built-in module, there's no need to do any kind of pip installs. Now the first thing I want to show is going to be just the basic setup of some code I want to time. Now what might look a bit strange at first is that we actually wrap our code in a string. So say, for example, I wanted to run a simple addition. Set up some triple quotes, make some space, and I'm going to say x is equal to 10, y is equal to 20, and I want to calculate the result of z, which is equal to x plus y here. So this string is basically evaluated by Timeit, it's ran, and then eventually we get the time at the end, so it's that simple. So the function we use from Timeit is actually itself called Timeit here. So I can set up a variable result equal to Timeit.Timeit here. And we can see this takes in a number of different things, and there's 3 of them that I want to focus on that I think are quite important. STMT, obviously we need some code to run, and that's this. So the statement just refers to that code to run here. The second one is number, and this is how many times to run the code behind the scenes, right? So recall in the previous example with the time module, we just run it once. This here is going to run it a number of times to give you a better idea as to how long it's going to take to run. And the last one is globals. Globals is a bit trickier. It basically refers to the namespace to use. So say, for example, if we wanted to use the math module in here, you could put import math at the top, somewhere like this, but that means we're importing the math module as the code to run, whereas in reality, like, if you want to work out something complex, adding the addition of how long does it also take to import a module, it's a bit redundant. So what we can do is import math at the top, and we can say use the global namespace. So I'll show that in just a second, but I'll show you the basic example first. So let's do stmt. The statement is code to run here. And you, in effect, if you're doing it as a really basic level, this is enough. So I could do result, this here. That'll be completely fine. You could do that. 0.02 seconds to get, well, let me show you the default number here. So it's doing this many runs here, and it's showing us how long it's taken to do this many cycles of executing that code. So maybe you want to change it. Say just do 1,000, and yeah, that's completely fine. 2.983 to the negative 0.5 here. So it's really up to you. You can run it as little or as much as you want to guess it. It probably depends on how complex the code is. If it's really slow, 1,000,000 might be too many times to run it. The next one I want to show is globals. So let me show you the problem that this kind of causes. If I was to do, let's suppose I wanted to do a new variable. Let's do a is equal to square root of z here. I put z in there, and I could do import math. Actually, we'll do from math import square root. It'll be a bit cleaner. From math import square root. So of course, if I try and run this, it complains because this isn't defined, right? So of course, it's defined up here. You could then take this and define it here, but of course, that means that we're also timing the import, and we don't want to do that. So if I run that, that's taking, it's taking this long to run. So what we do instead is we use the globals keyword. If I do from math import square root, right? Now, because I've imported this, square root is now available in the global namespace. So check this out. If I do print globals and call this function here, this will show all the things that are available here as to where I'm being called, right? So if I clear and run again, where can we see it? There we go, there. So we can see that the built-in function square root is available here. So what I can do is say, if I uncomment this, globals is equal to globals, the function call here. So basically I'm allowing all of the stuff from the global namespace to be available to the code that's running inside here. So now this shouldn't complain because I've said make this available. So if we clear the screen now and hit run, there we go, absolutely fine. So this is allowing the square root function to be available, but it doesn't get considered, the time to import this isn't considered as part of this running. And there you go, that's your really basic setup. If you're just starting out to time your code, this is more than enough just to get the ball rolling and time your code in a nice, efficient way. I really want to quickly cover a couple of benefits which makes this module really worthwhile. The first benefit of this is that the Timeit module automatically picks the best timer according to your system. So if you're on like a Linux or Unix system versus Windows or I don't know, anything else on Mac, right? The default timer on your system is going to be different on each of those systems. The Timeit module is clever enough to know which is the best default timer to pick, which is really nice. The second benefit is a little something called garbage collection. So as Python runs, it's going to deallocate resources in the background that aren't used. Now, whilst this might not have a massive effect, it still means that Python is doing stuff in the background whilst it's trying to do a computation, and Timeit just turns this off. So it'll turn it off, do all the runs, turn it back on. So it just means that there's processes in the background which are paused just to make sure that your results aren't as skewed. And the last one is that by default this is repeating. So we saw this this number equals x whatever. You can choose, okay, repeat this as many times as you like and give me the result. Whereas with the old example, it only does it once. So again, another benefit. And I think this raises a good case as to why you should be using Timeit to time your modules. What I want to do now is kind of run through kind of a trivial example, which is using a pretty poor prime algorithm and then making it better and better. And I want to show you how in practice we would be using this to time the function to then make improvements. So I've got the function from the start of the video, which is my particularly slow and awful function, which checks if the number's prime. Of course it's slow because it goes from every number from 2 up until, in this case, 73. And then if it evenly divides, it puts the number in here. And at the end, we return not bool of factors. So basically, if this contains nothing, then yeah, that means there's no factors mounted to it, and we can return true, which is all good. So what I want to do is time this, and then do a more efficient function and time that as well. So we're going to have 2 instances of time it running up at once, and then we'll kind of do a comparison to show how we can use time it to compare 2 functions. So if I just hit run real quick, just check they both run. There we go. I'll check the single one runs, I should say. I'm now going to pinch this and put it down below here. So to make this one better, I'm just going to call it is prime. I'm going to get rid of this idea of keeping track of all the factors here. And what we're going to do, rather than doing any of that, is basically say as soon as a number evenly divides, then, well, let's just stop there because we know it can't be prime. So say, for example, if it evenly divides by 2, all right? There's no point checking if 3 and 4 and 5 evenly divide, because if 2 already divides into it fine, then of course it can't be prime. So we'll do return false here, like this. And then if you make it to the end and nothing would divide into it, then yeah, it must be prime. So let's just check these guys side by side. We'll do is slow prime 73, so they should both work. Let's try 10, check they both work with one that is not prime, and we get false and false. So these are the things that we want to check. We want to check our slow function and our slightly better function here. So what I'm going to do is get rid of the prints because I don't want those to show inside the actual time it calls themselves, and just separate them out. So I'm going to temporarily just zoom out for a second, and let's just call this code A is equal to these quotation marks here. And we'll just kind of nicely wrap this up into its own little section. And then what we'll do is we'll then do code B. This is our slightly quicker one. And same thing again, we're going to wrap this up down here into its own little thing. So just to bear in mind, code A is the really slow one. Code B is the one that's a little bit better. So I can move in down here and begin my setup. As you can see, timer is already imported. So I can just call this, let's call this run1 is equal to timeit dot timeit. I'm going to pass in my statement. My statement in this case is code A. Run2 is going to be my one that's slightly quicker. And you know what? Let's just pinch this, put it down here, and say you can run code B. And then all we can then do is just kind of do the results together. So run1, that's going to go down here, and then we can then do run2, and run2 should go here. So this should be a nice way to see how timer is doing its job. It'll tell me how long does it take to run this a number of times versus how long does it take to run this a number of times here. Yeah, let's give it a go. Okay, 0.34 for the first one and 0.15 for the second. So yeah, this is proven to be a whole lot faster. Let's make this a bit bigger, just to try and make it a bit more exciting. And hit run. Okay, so look at that, the difference there. 2.15 seconds versus 0.15 here. Bear in mind, this, the Timeit module is running this a million times in the background, but it's really good to show, if you're doing these 2 tests, it's really easy to show how this scales up. So of course you can compare your initial work to your second work, and time it is just really nicely kind of wrapping them up and showing you here's how long this takes versus here's how long this one takes. There's one more thing I would like to show, which is the use of the setup input to each of these here, because of course if you look at what we're doing, we're timing how long the function takes to set up and call. So in some cases you can actually pass this setup in a different way and then just time the calling of that function. So let me quickly get rid of this here. I'll get rid of run1, actually no, I'll get rid of run2, and we'll get rid of this altogether. So just to finish off on, let me show you what this might look like. So we might have something like this. So what we want to do is time the actual operation of the code. So we can wrap the code here, and then let's just do code A is equal to, actually because that's just a single line, we don't need to do those single kind of quotation marks. We can just do it like this here. Let's call this something a bit nicer. I'll call this code to setup. So now we've got two strings. We've got the actual function, which is here to set up, and then we've got the actual code we want to run here. So if I do code A just for now, you'll see it does something not very good. Yeah, is slow prime is not defined. So that's because obviously it's running this with no kind of context of what's outside it. So what you can do is do setup is equal to code to setup. So it will do this first and then run this. So if I hit clear now, yeah, there we go, 2 seconds. To make it a bit quicker, I'll just reduce it by 90. There we go, 0.29. So this is, some situations this will be a lot better. So in this case, we're only interested in how long did this function take to call with an input of 10, ran, X number of times. And because we've done setup is equal to code to setup, the actual initialization of the function doesn't really play a part in timing how long this took. So just a little tip. In some cases, if you're setting up a dead simple function and you're not super fussed, then it's fine. You can do it all in the one big kind of group together. However, if you're being kind of really meticulous, put your code, your function call or whatever, in a separate space, pass that into the setup parameter, and then the actual code you want to time, whether that be a function call or a simple calculation, pass that in as your statement here. But yeah, that just about rounds that one off. Of course, if you're new to Python, I would definitely, of course, as we've discussed in the video, recommend using timeit rather than time. Time is generally for other things not related to this. But I hope this was helpful, guys, and I'll see you all in the next video. Cheers.